Okay, hello, this is Max. Spring 2015, CS61A, discussion 8. And working on reduce, we're in scheme. This is asking us to define reduce, where the first argument is a function that takes two arguments, the second is a starting value, and the third is a list. And this should work like Python's reduce. Quick reminder on Python's reduce. The way we expect reduce to work. The way we expect reduce to work is we are going to take, if I give plus and my starting value is 0, which is natural, and I do 1, 2, 3, 4, what I expect to happen mathematically is I'm going to first create 0 plus 1, and then I'm going to add that to 2, and then I'm going to add that to 3, and then I'm going to add that to 4, and I'm going to return the result. So it's starting with our starting value, and then each time it's sort of replacing our starting value. You can sort of see how that recursion is going to go. Right? It's replacing our starting value and adding it to whatever element we're looking at. If we were doing this on recurse, we could do it if we were doing this in Python, we could do this very easily with recursion. With iteration. Also do this easily with recursion. And in scheme, we're pretty much always going to do things recursively. So we have a base case, so we're doing this recursively, right? We have a base case. A reasonable base case is what happens if we get given a null list. So if list is null, well, we're going to define this. Is not specifically stated in the problem, but the way we'll define it is that if we get given a null list, we're just going to return our starting value. So anyway, so that's sort of an assumption we're allowed to make, and assumption we're going to make for this because it's not super explicitly stated. All right, okay, so this is our base case. Now, what happens if this doesn't work? What happens if if we don't get this base case, so if we get given a list that actually has something, well, if we get given a list that actually has something, then what we can do is we should just use recursion, right? We can recursively call reduce until we finally are out of lists to process, right? And how do we do it here? Well, we started with our starting value, and we applied our function to our starting value in the first element of our list. And then we sort of replaced, in our recursion, we sort of replaced our starting value for the next thing that we were using. So we were keeping track of our running total, as it were, inside of this S variable. And eventually we sort of get to the end of list to process, and we don't have any list left. And so we're just going to return a giant S. So you can sort of see how this S grows. And so we'll do the same thing in our reduce here. So I'm going to use the same function. And instead of, so a few ways to do this, but the way we're going to do it is we're going to apply a function to S, which is going to keep changing, and to the first element of list, to car list, and then we're going to CDR our list and begin processing the next element of our list. Let's make sure all our variables line up, or our parentheses line up. Boom, 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 boom. End our if statement, and then define is ending with this parenthesis, but we'll put it here. Okay. So how is this going to work? Well, let's give this as an example. So first, we're going to begin processing this list, and it's not null, so we're going to recursively call reduce again, but with something else. So we're going to do reduce plus, and now we've done 0 plus 1, which is equal to 1, right? And now we're looking at the list 2, 3, 4. Okay. And again, we don't have an empty list, so reduce, we use the same function, and now we're doing 1 plus 2. So now we'll keep track of that as a 3. Now we're just looking at 3 and 4, so on and so forth. We're going to get 6 here, and then finally we'll just be looking at 4 until we can reduce down to 10. And once we have an empty value, an empty value for our list, we're going to return whatever s is. In this case, s is 10, and so it's going to go all the way back up. Okay, so if you have any questions about this, feel free to post on Piazza or leave a comment on YouTube and we'll get them answered. Thanks for watching.